Hello there, our wonderful viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That special channel created for you and I to come together to tackle mathematics and demystify the age-long phobia often associated with this all-important subject, one topic at a time. I sincerely appreciate you for being consistent subscribers and viewers on this channel. Thanks and God bless you as you do. Today, we are continuing in our streak of the important topic of differentiation. In the last video, we looked at the product rule, how to apply the product rule in differentiating functions. And we said in summary that if you have y being equal to uv, where u and v are both individually functions of x, the y dx in that case is simply u dv dx plus v du dx. And we looked at three different questions to see how that pans out. Today, we are looking at the other aspect of differentiation, which is quotient rule. Quotient basically in mathematics means division. So it goes this way, that if y is equal to u over v, that's a fraction or rational function, where again u and v are functions of x, then dy dx by formula is v du dx minus u dv dx all over v squared. It's a strict formula we must adhere to solving questions under quotient rule. Without wasting time, let's delve into questions to see how this plays out. For question 1, we define dy dx if y is equal to 3x squared plus 8x minus 2 over 5x plus 4. So if you have this clearly a quotient, because when you have an exam, you will not be told to use product rule or quotient rule. The question will just be thrown at you. It's now left for you to determine if the question is under quotient or product. This evidently must be product because you're having a fraction here. So that means this is actually a quotient rule problem. And for quotient rule, the numerator is strictly your u and denominator is strictly your v. Unlike in product, where you have the liberty to either make the first one your u and the second one your v, or the first one your v and the second your u. In this case, the numerator must necessarily be your u, while the denominator must necessarily be your v. So let's quickly see how to solve this using the quotient rule. So dy dx is saying that v untouched, and that is 5x plus 4, that is v. Du dx, that means differentiate u with respect to x, and that means you have a 6x plus 8. So this is v, this is du dx, meaning write v down, differentiate u. Then we switch rows after the minus. This time around, write u down first. We will have 3x squared plus 8x minus 2. That is u. Now differentiate v. V is 5x plus 4. So differentiating that, I'm going to have simply 5. Then over, now v squared is not differentiation, just square of v. And v is what? 5x plus 4. All squared, and that's it. So this is v differentiate u minus u differentiate v all over v squared. And as a matter of fact, differentiation actually ends here as the topic. However, what follows is simply algebraic expansion. So let's go. We have what here? Opening the bracket, I'm going to have 30x squared plus 40x, that is 5x times 6x, 30x squared, 5x times 8, 40x. Then I'm having 4 times 6x, 24x, and 4 times 8 is 32. That's the expansion for the first product there. Then here I'm going to have minus, the 5 multiplies everything there, we're having minus 15x squared minus 40x, then plus 10. Because 5 times 3 is 15, 5 times 8 is 40, 5 times 2 is 10. So the minus just affect everything in the bracket. You have a minus, minus, and plus. Divided by 5s. You need not bother expanding the denominator. It's not necessary. So at the numerator, all I need to do is to just correct my like terms. So 30x squared minus 15x squared. I will have 15x squared again. Now here, 40x minus 40x, that is 0. I'll be left with 24x, like terms, 24x. And lastly, 32 plus 10, that is 42. Then all over 5x plus 4 all squared. And that is the differentiation by quotient rule of this problem. I believe you find quite straightforward. Okay, let's look at our second example. Stick on quotient rule. Stick on quotient rule. Now we have example 2. If y is equals to cosine x plus 2 over sine squared x. This is clearly a quotient problem, whereby this is my u and this is my v. Note that sine squared x can be written as, so this is my numerator. For simplicity, this is actually sine x all squared. That's the meaning of sine squared x. So how do we solve this? Now we have to bear in mind again that when we have brackets, we must think of functions on functions. So we have a quotient rule with functions on functions here. So we have the y, the x equals to v. V is simply sine x all squared. That's my v. Differentiating my cos. Bear in mind that we have a function of function here. The internal there is 1. And external is what? Minus sine x plus 2. So this is my v, denominator, differentiating my u, which is a function of function. Then minus, what's my u this time around? Is now cos x plus 2. Differentiating my v, the v dx now. Remember, this is function of function. Internal will give me cosine x. And external will give me 2 sine x. This time around the power of 1. So internal cosine, external 2 sine x all over. My v is actually sine x squared originally. And now we are squaring v. That's going to become sine x squared, again all squared. The first square came with the question. The second square is coming from the formula v squared. So all that we are left with is to simplify further. And this is going to be simply minus sine squared x, the first one, then dot sine x plus 2. Dot is often used to replace times. Then we have here minus 2 cos x sine x, and then cos x plus 2, right? All divided by sine x to the power of 4. Because indices, this 2 times 2 is 4. Now there's something important here, actually under trigonometry. Sine x cos 2 sine x cos x is actually sine 2x. Hence, we can see finally that we have minus sine squared x, sine x plus 2. The minus is actually sine 2x. So the entire value here is sine 2x. Then cos x plus 2 all over. Then we have the sine 4x. Because we guys I wrote for the beginning here. So the 4 would as well come in a sine to the power of 4x. And that actually is the solution to that differential equation there. So to solve in quotient approach, all you need to do is to use the formula. Of course, first identify that the numerator is your u and denominator is your v, and that the formula goes thus: dy dx equals to v du dx minus u dv dx over v squared. And by so doing, you be careful in solving each of them and piecing them together by mere subtraction, and voila, the answer. And that's been our lesson for today. Very brief, very interesting. However, I must not fail to tell you that to gain proficiency, you have to expose yourself to solving many questions, as many as possible. The more you solve problems in mathematics, the better you become. As I often tell my students that, see, you don't become an expert bicycle rider in a day. When you learn any new skill, it's very, very obvious that you're going to make a lot of mistakes. What is very certain is that you're going to fall at the very beginning, but don't ever quit. Quitting is not an option if you must gain that much desired proficiency and mastery. So similarly in mathematics, when you learn as a beginner, it's quite understandable and expected indeed that you're going to make a lot of mistakes. And don't forget that without mistakes, you don't become a master. So mistakes takes you to the level of mastery. With that, I end the class today. And if you enjoyed this class much as I did, please don't forget to like, share, subscribe, and comment. And most importantly, put in your button of notification so that you'll be the first to know when our next video drops. Thanks and stay blessed.